It's spinning once every 5.5 hours. That means the front edge is like 50 m an hour as fast as it is, as though it's creating artificial gravity. What's your take on that planet that's supposed to be outside the Kuiper belt that's so far, planet N9 so far? Yeah, all the data looks convincing. As we venture beyond the familiar planets of our solar system, the Kuiper belt and the Oort cloud emerge as two fascinating and mysterious regions. These distant zones are home to icy bodies, dwarf planets, and the origins of many comets, yet they are also shrouded in mystery. With NASA's New Horizons spacecraft providing groundbreaking data, new discoveries are reshaping our understanding of the Kuiper belt, its possible size, and its role in the solar system's history. Meanwhile, the Oort cloud, though never directly observed, continues to intrigue scientists with its theoretical significance as the edge of our solar system and a link to interstellar space. The Kuiper belt is a vast, donut-shaped region of icy bodies that surrounds our solar system, beginning at the orbit of Neptune, about 30 astronomical units, AU, from the Sun. For reference, 1 AU is the average distance from Earth to the Sun, approximately 93 million miles. This region stretches outward to about 1,000 Australian dollars, making it one of the most extensive structures in the solar system. The Kuiper belt is home to a variety of icy objects, including dwarf planets like Pluto, Haumea, and Makemake. It contains remnants from the early solar system, objects that never coalesced into a planet due to the gravitational influence of larger worlds like Neptune. The Kuiper belt's structure and composition offer scientists a glimpse into the conditions that existed during the solar system's formation. Interestingly, the Kuiper belt has two distinct regions. The inner Kuiper belt is more densely populated and relatively stable, resembling the asteroid belt between Mars and Jupiter but on a much larger scale. Objects here, such as Pluto, tend to have well-defined orbits. The outer Kuiper belt, or scattered disk, extends beyond the inner region toward the edge of the solar system. It is a chaotic zone with erratic orbits that are still evolving. Objects here are less densely packed, and much about this region remains unknown. NASA's New Horizons spacecraft, famous for its historic flyby of Pluto in 2015, continues to explore the outer reaches of the solar system. During its journey beyond Pluto, New Horizons made a surprising discovery that challenges our understanding of the Kuiper belt's size and structure. As the spacecraft traveled between 45 Australian dollars and 55 Australian dollars, it detected higher than expected levels of dust and Kuiper belt objects, KBOs. This finding contradicts previous models that predicted a significant drop in both dust density and object population in this region. The results suggest that the Kuiper belt might extend farther than initially thought, with the inner Kuiper belt possibly reaching as far as 80 Australian dollars. Alternatively, there could be a second, previously unknown Kuiper belt beyond the scattered disk. If confirmed, this discovery would reshape our understanding of the Kuiper belt's structure and dynamics. It also raises intriguing questions about the distribution of material in the outer solar system and how these regions interact with interstellar space. While the Kuiper belt marks the outer edge of the solar system's disk, the Oort cloud is a spherical shell of icy bodies that surrounds the entire solar system. The Oort cloud begins where the Kuiper belt ends, at approximately 2,000 Australian dollars from the Sun, and extends to about 100,000 Australian dollars or 1.5 light-years. It is so distant that it resides in interstellar space, far beyond the influence of the Sun's gravity. Unlike the Kuiper belt, the Oort cloud is entirely theoretical. No objects within it have been directly observed. Scientists infer its existence from the behavior of long-period comets, which are thought to originate in this region. Long-period comets take more than 200 years to orbit the Sun, in contrast to short-period comets, like Halley's Comet, which are believed to come from the Kuiper belt. The Oort cloud is thought to have formed from planetesimals, small, icy bodies that were flung outward by the gravitational influence of the giant planets during the early solar system. While the Kuiper belt remained relatively close to the Sun, the Oort cloud objects were pushed to extreme distances, where they are now held in place by the gravitational pull of the Milky Way galaxy. The Kuiper belt is believed to be one of the oldest surviving remnants of the solar nebula, the massive cloud of gas and dust from which the Sun and planets formed about 4.6 billion years ago. Initially, scientists theorized that the Kuiper belt might have contained enough material to form a planet, but this did not happen due to the gravitational influence of Neptune. Neptune's presence disrupted the orbits of objects in this region, preventing them from coalescing into a single large body. Instead, these icy fragments were left to form a diffuse belt of debris. Some scientists also proposed that Neptune's migration outward from its original position scattered much of the Kuiper belt's material into interstellar space, leaving behind only a fraction of the original mass. According to the NICE model, a leading theory for the Kuiper belt's origin, the giant planets, Jupiter, Saturn, Uranus, and Neptune, did not form in their current positions. Instead, they migrated over time, with Jupiter and Saturn moving slightly outward and Uranus and Neptune being pushed into the icy outer regions of the solar system. This migration caused a gravitational upheaval that flung smaller objects outward, creating the Kuiper belt as we know it today. The NICE model also explains the peculiar orbital relationship between Pluto and Neptune. Pluto, a prominent Kuiper belt object, is in a 3:2 resonance with Neptune, meaning that for every 3 orbits Neptune completes around the Sun, Pluto completes 2. This resonance helps stabilize Pluto's orbit, preventing collisions with Neptune despite their overlapping paths. Given its size and structure, some scientists speculate that the Kuiper belt might have been the building blocks of a failed gas or ice giant. Without the gravitational influence of Neptune, the material in this region might have come together to form a planet similar to Uranus or Neptune. However, Neptune's gravity disrupted the region, preventing this from happening. Despite its vastness, the Kuiper belt is surprisingly sparse in terms of mass. The total mass of all known Kuiper belt objects is estimated to be only about 10% of Earth's mass. This raises questions about where the missing material went. Some of it was likely ejected from the solar system during the chaotic early years of planetary formation, while other parts may have collided and broken apart into smaller fragments. The Kuiper belt and the Oort cloud are 2 distinct regions of icy bodies in the outer solar system that differ significantly in structure, origin, and location. The Kuiper belt is a flat, donut-shaped disk lying within the plane of the solar system, located between 30 and 1,000 Australian dollars from the Sun. In contrast, the Oort cloud is a spherical shell that surrounds the solar system in all directions, beginning at around 2,000 Australian dollars and extending to 100,000 Australian dollars. The Kuiper belt is the origin of short-period comets, which complete their orbits around the Sun in less than 200 years, while the Oort cloud is the source of long-period comets, whose orbits exceed 200 years. Another key difference is observability. Kuiper belt objects such as Pluto and Haumea have been directly observed, whereas the Oort cloud remains theoretical and has not yet been directly detected. NASA's New Horizons mission has provided invaluable insights into the Kuiper belt and its potential boundaries. With enough propellant to continue operations into the 2040s, the spacecraft may uncover more surprises about the size, structure, and composition of this distant region. Meanwhile, advancements in telescope technology and future missions may one day confirm the existence of the Oort cloud and provide a deeper understanding of its role in the solar system. For now, these outer regions remain some of the most enigmatic and exciting frontiers in space exploration. In exploring the Kuiper belt and the Oort cloud, scientists are not only uncovering the history of our solar system but also gaining clues about the formation of other planetary systems across the galaxy. As our understanding grows, these distant regions may reveal their secrets, bringing us closer to understanding the universe as a whole.